Hey everybody, and welcome to the next video for the project Build a Data Analysis Library from Scratch in Python. In this video we will be manually testing our data frame in a Jupyter notebook. Okay, so we've already formally tested our data frame, or at least all of Pandas Cub, with the PyTest library. But in this notebook, or in this video, I want to show you how to manually test out your data frame in a Jupyter notebook. So oftentimes you'll want to, really see how your data frame is behaving with how you would actually use it. And since most or a lot of data analysis is done in a Jupyter notebook, then it can be a good thing to go ahead and use your data frame just as if you were using it to do data analysis. So let's go ahead and open up a Jupyter notebook so I could show you how I work with the data frame as I'm building it and as I'm testing it out. I'm going to go ahead and open up this test notebook. Okay, so first of all we can see that we're using the Pandas Cub kernel, which means that, and then this will verify again that we're in the Pandas Cub environment. So this is a very important piece I want to show you. This is a magic function called auto reload. And so this is not Python code. This is what's called a magic command. So this will only work in IPython or Jupyter notebooks. It will not work if you want to execute just normal Python. So there's a magic command that does something special, and in this case it will reload any changes to your files back into the notebook. So normally, let's just say you're working in this one dunder-init.py file, and you make a change, and if you've already opened up the notebook, that change will not be reflected unless you restart the kernel. So you would have to completely restart the kernel, and you'd have to re-execute everything that you've done up until that point. Now, what auto reload does is it allows you to change some code, and then without restarting the kernel, see how the changes reflect as you're working. So this actually saves a tremendous amount of time when you're developing. So you can make some changes, check how they visually inspect what's going on, and then make some more changes and iterate like that. So it does save quite a bit of time. So this is quite a useful magic function. So I'm going to go ahead and execute that. I'm going to go ahead and import our libraries. So NumPy will be used simply to help us make our data frames. Pandas Cub at its current state is just the shell program. There's nothing that has been implemented thus far. It is basically empty, although it will properly import, and we saw how to import it in the previous video. Pandas Cub Final is what the final version of Pandas Cub will look like. So I put this in here so you can play around with the final version of Pandas Cub and to see how it works when it's complete. And then I've also imported pandas so that you can also experiment with the pandas data frame, since our data frame is essentially meant to emulate the pandas data frame. Okay, so let's go ahead and execute that cell. Now, in this cell we create those three data frames: one for Pandas Cub, one for Pandas Cub Final, and one for pandas. And it uses just a dictionary of strings mapped to one-dimensional NumPy arrays, and we'll see how that works out later on in the project. So I went ahead and instantiated. So what I did was I created three data frame instances, one for each of the libraries that I imported that have data frames. And now I'm going to output the visual representation of each data frame in the notebook. So df is simply Pandas Cub in the current state, and there's actually no representation for it whatsoever. So you will not be able to see anything just yet. Again, it's just like an empty shell. So there's no visual representation. There's simply a place in your address in your computer where it's currently residing, with actually no data in it. DF final is the Pandas Cub final, and DF Pandas is what Pandas is going to be, what Pandas produces. So the end result, the data frame will look fairly similar, or very similar to what Pandas does, and I'll show you how to produce this when we get to that step. But for now, I really want to focus on the process of iterating back and forth between the source code and between the Jupyter notebook, where you can actually see how things are working. So let's go ahead and let's go back to the source code and make some changes just so I can show you what this does. So here's Pandas Cub, okay, and whenever you instantiate your class, this Dundry init special method is called. So this method is actually already implemented for you. You won't be editing this one, but I do want to add something in here just so you can see what happens whenever we make some changes in the notebook. So in init method. So I just added a simple print statement, print function, at the end of this initialization method, which always gets run whenever you instantiate a class. So if I go back over here, normally you would have to restart the kernel in order for this change to be reflected. But since we did auto reload, this will detect that change and automatically provide those changes for us. So I'm not going to re-import anything over here. I'm simply just going to run the initialization again. So I'm going to run this statement. In fact, I can just run this one just by itself in its own cell. So I have not executed any other cells yet. So let me just go ahead and execute this, and you can see that very nicely it has propagated those changes, and it reflects those changes that I just made. So this will able to help you quickly prototype, quickly write code without having to go back and forth. So this is why I'm showing you this method. It is something that I use, and I believe it is something that is very valuable when you're developing, and it will give you a way forward to quickly iterate your ideas. Okay, so that is how you would manually test out your data frame in a Jupyter notebook. It'll allow you to see whether your results are matching. Instead of like just getting results from PyTest, you can now go into the notebook and in fact see how your data frame is working here outside of just the manual or the automated testing, I should say, that PyTest provides. Okay, so that's it for this one. Hope you guys enjoyed it. Thanks.